Hey guys, today we're going to take a look at the quadratic formula and remember how to use it. You use this quite a bit in Algebra 1, so we're going to take a look at that again and hopefully it looks familiar to you. You're going to need a calculator for sure and your notes to be taking good notes today and working through a few examples with me. So we've been talking about how we solve using factoring, square roots, completing the square. And I'm sure you've noticed that completing the square process is the same process over and over and over. No matter what the problem looks like, we modify it to create a problem that follows the same steps and procedures. And when that happens, when a process is repetitive, someone eventually is going to find a way to make a formula out of it. So completing the square and that process helped us develop what we remember as the quadratic formula. So if you want to see that all worked out, you can go ahead and ask me about that tomorrow. It's quite an interesting write-up there on how they came about at this quadratic formula. So the quadratic formula, for your notes, make sure you write it down, is x equals. So the solutions to x will be the opposite of b, or negative b, plus or minus the square root of b squared minus 4ac all over 2a. And this is going to give us the solutions to any sort of quadratic equation that we have there. Anything with an x squared in there, anything that's quadratic, we can solve or find the solutions using the quadratic formula. It comes from completing the square, but without all those steps that we had to go through the last few days, without all of those being shown each and every time, we just go straight to the formula to find our answer. Now this b squared minus 4ac, the stuff underneath the radical sign, that has a special name. That's called the discriminant. Basically, it tells me about my solutions. If that number underneath that square root works out to be a negative number, then my solution is going to be imaginary. If it works out to be a perfect square, then I know I have rational answers, real answers. Irrational answers come from when that number underneath the square root is not a perfect square number, so one that we have to simplify the square root. Then I'm going to get irrational answers. So that discriminant, that number under the square root, plays an important role in giving us those solutions. Let's take a look at three examples today of using the formula. Here's the first one, x squared plus 2x minus 8 equals 0. And we're going to use the quadratic formula, so I have it up there on the side. The quadratic formula says the solutions for x are going to equal, and then we go ahead and we pull the numbers from our equation here. Remember that the a is in front of the x squared, the b is in front of the x, and the c is the constant here. So we'll go ahead and grab those numbers, grab those coefficients, the constants, and stick them in there. So negative b, or the opposite of b, well, if my b is 2, I'd write negative 2. Plus or minus, square root. Underneath the square root, I have the b squared minus 4 times the a times the c. The c is negative 8. All over 2 times the a. Now all the numbers are placed in there. We just go about simplifying this or figuring out what this value is. So my next step here, I would say negative 2 plus or minus. I'd want to figure out what's going on underneath that square root. So underneath that square root, I'd have 2 squared, that's 4. And then I have a minus or subtract 4 times 1 times negative 8. This is going to become plus 32. Negative 4 times 1 times negative 8 is adding 32 over 2. Negative 2 plus or minus 4 plus 32 is 36. Ooh, the square root of 36, that's one we know. That's just 6. So far my answer is negative 2 plus or minus 6 over 2. Now I just need to figure out what two answers or what two values this is telling me. So what I would do is take negative 2 plus 6, which is 4, and then divide it by 2. That gives me a solution of 2. So x is 2. I also take the other part, negative 2 minus 6. That's negative 8. Divided by 2, negative 4. Negative 4 is my other solution. So I had those two solutions that I can find. They're nice integer values because my perfect square 36 turned into a nice integer 6. Okay, so the quadratic formula gives us those two solutions. Not everyone's as pretty as that one, okay? Here's example 2. We're going to go ahead and solve this again using the quadratic formula. So same setup. The x, or my solutions, are going to equal. And I'm going to go ahead and place those a, b, and c values in where they go in the quadratic formula. It starts with the opposite of b, or negative b. The b here is negative 6. So if I were to take the opposite of him, I would end up with positive 6. So I'd write 6 plus or minus square root, the b thing squared, so that's negative 6 squared. I put parentheses around my negative and the 6. It's very important because if you type it in a calculator, you're going to end up not getting the right answer, okay? Make sure that we square the negative 6 and not just a 6. So minus 4 times a times c all over 2 times a. And now we'll go ahead and simplify this. My next step, 6 plus or minus, what's going on underneath the square root? What's that discriminant here? So negative 6 squared is 36. Minus 417 here, that'd be 28. So 36 subtract 28 all over 2. So far I have 6 plus or minus square root. Go ahead and figure out what 36 minus 28 would be. Okay, go ahead, and if you need to type that in your calculator, you're okay. It's 8 all over 2. And then now we would want to take a look at simplifying that square root of 8. Square root of 8 is the square root of 4 times the square root of 2. Oops, let's write that correctly. So that would lead me to 2 square roots of 2. So far I have 6 plus or minus 2 square roots of 2 over 2. Now when you take a look at this answer, we can't really come up with an integer value here because of that square root of 2 in there. But 6 and 2 are both being divided by 2. So we'll go ahead and do that. 6 divided by 2 is 3, plus or minus 2 divided by 2 is 1. So 3 plus or minus 1 square root of 2. Those are my two values for x. Those are my two solutions. Okay, let's look at a third example. This one starts a little differently because it's x squared equals negative 2x minus 7. We want to make sure that our a, b, and c are all to one side and it equals 0, just like we do when we factor. So I'm going to go ahead and add 2x and add 7 to the other side. So I end up with x squared plus 2x plus 7 equals 0. So again, the a, the b, and the c are the coefficients and the constant of our problem. So here we go. Negative b. So negative 2 plus or minus square root the b squared, 2 squared, minus 4 times the a times the c, all over 2 times the a. So I'd have negative 2 plus or minus square root, 2 squared is 4, minus 4 times 1 times 7 again is 28, all over 2. So I'd have negative 2 plus or minus square root 4 minus 28 is negative 24 over 2. Now that negative in that square root, okay, that's the discriminant. Negative 24 for a discriminant tells me that I'm going to have imaginary solutions here. I'm going to need to use I. So when I break apart that 24, I'll use 4 and 6. So I'll have 2 square roots of 6, but I'll also need to include an I in there. So negative 2 plus or minus 2I square roots of 6 over 2. And just like the last example, dividing by 2 here, we're going to go ahead and do that part. So I'd end up with negative 1 plus or minus 2 divided by 2 is 1, so 1I square root of 6. My solutions for x are negative 1 plus or minus I square root of 6. So I got my two solutions. They happen to be imaginary. So we're going to take some time over the next few days to practice our quadratic formula and get a better feel for how all of these methods tie together. Thank you for taking good notes.